Welcome to our next deeper look video. This video is going to be focused on moon phases. So moon phases as a topic is one that is a big part of our curriculum. It is also something that you probably learned about in a smaller form in a previous science class. And it is one that we can have quite easily real-world observations that help us to reinforce these concepts that we're learning about. So it's an interesting topic because we have a lot of knowledge that we think we're bringing to the class. Some of that knowledge is incorrect, misconceptions that a lot of people of all different ages and backgrounds have. And so we want to recognize that we'd like to come into this with an open mind and make sure that we feel confident with all of the different things we're going to be learning about in our lecture videos, and that we take the time to build this diagram as I go, that you're building it in your notebook as well, to reinforce the things that we're learning about and to recognize if there's questions that you want to ask or ideas you want to follow up on. So the Earth-Moon system is one that we could view from any different direction. We could be top down looking at the North Pole of the Earth. We could be bottom up looking at the South Pole. And we could be in any part of Earth's orbit around the sun, which means sunlight could be coming in from any direction. We will try to be consistent both in the lecture slides and any other resources we use, as well as this video, just to make sure that we're not complicating things. Sunlight has to come in from a direction. So we're going to have it come in from the right side of our page because that's what we're going to see most consistently in our other resources. So sunlight is coming in from the sun that is very, very far away in that direction. From that, we will then be able to think about what is lit up and what is dark based on the fact that sunlight is coming from a single direction, so anything on this side of an object would be dark. So let's think about that in the context of the moon's orbit around the Earth. So we're going to have the Earth here. And I want us to recognize that the Earth is experiencing light when we're thinking about the side that is facing the sun. So this side is lit up and it's daytime. And this side is dark and it's nighttime. I don't know if that's too small to see, but I've drawn it anyway. So daytime and nighttime. And the Earth is rotating, so this is going to be the last video where I rotate in place, but we might as well. The Earth is rotating every single day. And so when we talk about daytime and nighttime, we know that we're talking about any given moment in a day, and that's not the same for a single patch of the Earth every day, every year. Everything's experiencing daytime and nighttime. So if we're here on the Earth and we're kind of looking in the direction of the sun, that would be noon. And if we're over here, it would be midnight. And although we've seen these kinds of things in the slides, we want to recognize that it is really useful for us to be drawing them. And to go from here to add anything else, we actually have to recognize that it is not something we have to memorize, but we do need to know that if we are looking top down, so northern hemisphere focus, if we're looking top down at the North Pole of the Earth rotates counterclockwise, and the moon itself is going to orbit counterclockwise as well. And we saw this already with the Earth's orbit around the sun, and that's just how the whole solar system got set up. The big swirling cloud of gas that formed the solar system, which we'll be talking about soon, was just swirling in a particular direction, and this is the direction that, that things tend to go in. What that means is if we are spending time after noon, so this person is then rotating, if we're looking this direction, it is afternoon and before midnight, but we're leaving from day to night, so that is sunset. Hopefully that makes sense in our understanding of time. And then again, if we continue past midnight and towards noon, and we're going from night to day, than if we were standing here looking, we'd be looking at sunrise. And I want you to recognize that this is consistent with what we've drawn so far, even without any moons. If I am standing here, so this is my hand being the person standing on the earth, out of my peripheral vision, I can see the sun, but it is soon going to leave my view, which means it is sunset, the sun is leaving my view. And if I'm standing over here at midnight, then the earth itself is blocking my view of the sun, so there is no sun. If I'm standing here at sunrise, the sun is going to be coming into more of my view. And if I'm standing here at noon, then the sun is high in my sky. So those terms I hope that we feel comfortable with. They show up in our lecture videos too, but we built them from scratch, which is why these deeper look videos are so useful, is we're not just getting finished diagrams, we are drawing them into our notes and able to pause and rewind if there was something we didn't quite understand to make sure that we're building diagrams that we feel confident in. So now let's talk about the moon. We're going to start with the moon up here. So at the top of our view, and we want to recognize that this would be the side of the moon that is lit, and this would be the side of the moon that is dark. And so if we were watching it, so this is the actual space view. If we were able to take a photo of it, it would be right around sunset, that it would be very high in our sky. And so high in the sky at sunset, we're going to keep track of our photos here. We would see a moon where we are physically looking and the left side is dark and the right side is lit. We would see a moon that looks like this. So we're facing south to take our picture because it's high in the sky, and the highest point anything gets is in the southern sky, or along the meridian, so along the southern sky for the moon. And so that would be the photo we would take if we were at sunset looking at that particular moon. But I want us to recognize that if we were thinking about this moon instead, this is still the side that's lit up, because remember, the sunlight is coming in from over here, and this is still the side that is dark. And now it's going to be easier for you to turn your page around rather than try to stand on your head. But if I try to stand on my head, I can see that if I am looking at this moon, the left side is lit up from my point of view, and the right side is dark. So high at sunrise, sunrise, we took this picture. We have to face south to catch that high in the sky moon. And again, you can turn your picture around to double check this, but the left side would be the part that is lit up, and so we would get a moon that looks like that instead. So that's part of how we want to be able to use this diagram, is to think about what that person would see at different times of day for different moon phases. So let's add 2 more moons to this diagram before we go any further. I'm going to draw this one here. So note that this would be the side that's lit up. It's the side that's facing the sun. But the side that is facing the Earth is all dark. It would be the night side of the moon that we're seeing, which means we don't see it at all. So high in the sky at noon, we would see the sun, but we would not see the moon here. And then on this side of my not quite perfect circle, we have the day side of the moon, nice and fully lit up, and then this would be very dark. So let's add our picture here. I'm not going to draw the high at noon moon because it's not visible. High at midnight. We're facing south to take this photo because that's where things are when they are high. And when we look at this moon, we can see the whole thing lit up. So we've got a couple of different snapshots of these moons, and we want to start to give them names. So let's do that. This is the start of what we call the cycle of the moon's phases, and this is a new moon. It's new because it's the start of the cycle, which is somewhat arbitrary, but it's empty. That seems like a great way to get started, is with an empty moon from our point of view. We don't see any of the lit up side, so we call that the new moon. If we look to get from the new moon over here is a quarter of the cycle, which means that this is the first quarter moon. Not because it is a quarter lit up. This is a half circle, but this first quarter moon looks like this half circle lit up on the right side, and it's named that because it's a quarter of the way around the circle. Over here, we have the full moon. So this is the full moon, high at midnight. And this is, we could have called a second quarter moon, or half of the cycle, halftime moon, but we call it a full moon. It's beautiful, it's bright, it's what the majority of media tends to portray the moon as. And it's only the full moon that is really high at midnight. We've already got these two other examples that show us that the moon is rising and setting at different times throughout the year, and that's going to be something we explore more in the lecture videos as well. So new moon, first quarter moon, full moon, then we go around, and at this point, by the time we get to this moon down here, we've gone 1 quarter, 2 quarters, 3 quarters of the way around. We want to call this a third quarter moon. And there are a lot of different resources online that call it a last quarter. I strongly recommend that you do not call it that, because if you think about any kind of sporting event that has quarters, the last quarter is the 4th quarter. That would be over here. The third quarter moon is happening 3 quarters of the way around the cycle, and there's still lots of moon cycle left. So let's call it the third quarter. Let's work hard to not use any other term for it. It is a third quarter moon. So this would be a picture of that third quarter moon. It's high in the sky at sunrise, and the left side of it is lit up from our point of view. It is just these 4 that have these special moments in time that are only that one night or only that one day that we could call it that particular moon phase. However, what we want to recognize is that there is this whole in-between time. So let's focus here where there's a little bit of space. All of the different times, and I'm going to kind of draw dashed lines of all the different nights that we're kind of looking, where it is after a full moon and it is not yet a third quarter moon. All of those moons, if we were to draw a whole bunch in this from sky view, would be less than fully lit up. So from Earth view, this would be fully lit up. This would be the left side lit up only. So the outside of this circle, I'm going to draw the from Earth view. And each one of these days is going to be a little bit less lit up. But every single one of these shapes, and they look kind of similar to each other, I apologize for that, and I see that this one might be cut off in our view. We're going to be okay with that. Every single one of these has a shape name that we're going to call a gibbous. That is different than the shape name called a crescent, which we'll draw in just a little bit. And it is getting less and less lit up from our point of view, so we would call that a waning gibbous. Waning indicates that it is getting less lit up from our point of view, and gibbous is the shape name. Let's instead focus on this quadrant here. So all of the different nights or days that we're looking for the moon throughout the course of this amount of time. It's after new moon and before first quarter. So that first quarter moon is going to be half lit up on the right side. The new moon is not visible at all, so I'm not even going to draw it. This is, again, on the outside here is going to be the from Earth view. And for all of these different moons, we're going to have these shapes that are, if I'm going back in time, getting progressively less and less illuminated. tiny, tiny sliver. And each of these shapes that I've drawn is a crescent shape. So that is the name of the shape itself. And it's from new moon, moving forward in time. It is getting more and more and more and more illuminated from our point of view. That is a waxing crescent. So getting back to a place where you can see me. When we think about all of the different nights and days of the year, what we want to recognize is if we see this particular crescent shape in the sky, it is actually going to be highest in the sky at about 3 p.m. because it's high in the sky after noon, but it's high in the sky before sunset. And it will have actually risen into view at about 9 a.m. and it will set by about 9 p.m. So it's in the sky for this whole period of time if we're looking at this particular waxing crescent. So this diagram, if we really explore it and investigate it and continue to draw it and come back to it over the moon phase topic, can help us think about what order the moon phases go in, how long they last, and when we've got these terms in mind, when they become visible and leave our view and get very high in the sky. The last thing I'll leave you with, because I am running out of space here, is a mnemonic that a student told me about once, which is DOC. And that helps us think about the order that these things go in. We have the right side lit up when the moon is waxing. When we see the whole circle, we have a full moon. And then when we see the left side lit up, we have a waning moon. And that is the order. So DOC, like me, can be the way that you keep track of which side of the moon is lit up for the different parts of the process. So there's a lot here, but remember, this is why we build this from scratch. When we started this video, this whole thing was empty. We built it as we went and recognize you can always go back and rewatch, you can go back and redraw, and I encourage you to do so. So I will leave this up empty for a bit as I finish up the video. Thanks for watching, and I'll see you in the next one.